Welcome everyone. Imagine a smartphone that can project a crisp, three-dimensional image above its screen, allowing you to view and interact with content in mid-air. This is not science fiction anymore. Holographic smartphones are in development, and 2026 could be the year we see the first consumer-ready models hit the market. These devices use light field technology or diffraction-based optics to create floating images that appear to have depth and volume. The effect is striking, especially for video calls, games, and digital design. Unlike traditional three-dimensional screens, holographic displays do not require special glasses or headsets. Instead, they manipulate light in such a way that each eye sees a slightly different image, resulting in natural depth perception. This creates a true holographic illusion. Some companies are developing this through micro-lens arrays, while others are experimenting with laser projection and eye tracking systems that adjust the image in real time depending on your viewing angle. One key player is Layer Inc., which has already released tablets with basic light field displays. Their new prototypes aim to shrink the technology into smartphone size. Meanwhile, Samsung and Apple have filed patents for volumetric display systems, suggesting that larger tech companies are preparing their own entries. Chinese manufacturers, such as Xiaomi, are also rumored to be testing three-dimensional camera modules that work in tandem with holographic output to create immersive augmented reality interactions. Why would you want a holographic smartphone? The applications go far beyond entertainment. Doctors could use them for three-dimensional imaging during telehealth appointments. Architects and engineers might review models without the need for virtual reality gear. Gamers could experience real-world environments blended with interactive elements. Even texting might evolve with emojis or hand gestures hovering in the air above your phone. Business use is just as compelling. Imagine presenting a product prototype in 3 dimensions during a video call, or sharing a miniature data dashboard that colleagues can view from different angles. Sales teams could use holograms to showcase product features. Designers might manipulate models on the fly with touchless gestures. The benefits of holographic presentation could transform sectors such as retail, real estate, and education. Creating convincing holograms on such a small device is technically difficult. Engineers must optimize display resolution, brightness, and viewing angle, while keeping the device portable and efficient. Eye tracking software has to run smoothly and react quickly. Graphics processors need to render multiple perspectives in real time. Battery life becomes a critical concern since these features consume a lot of power. Another challenge is optimal content. Holographic devices require new kinds of visuals designed for depth and perspective. Video creators and app developers must rethink interfaces. New file formats and rendering engines may be required. It's not just a hardware revolution, but a software one as well. Companies that build the most intuitive holographic experiences will likely shape this emerging field. Augmented reality has laid some of the groundwork. Apps like Pokémon Go and AR navigation tools have introduced millions of users to spatial content. Holographic phones take this further by removing the dependency on background surfaces and overlays. Instead of superimposing digital data on the real world, these devices project the digital directly into the air, providing a more immersive and flexible experience. Battery efficiency and thermal management will play a critical role in the future of holographic smartphones. Rendering high-resolution three-dimensional visuals in real time requires significant processing power, which can quickly drain batteries and generate heat. Engineers are now exploring new chip architectures, low-power lasers, and graphene-based cooling systems to address these challenges. Solving these technical hurdles is essential to making holographic displays practical for everyday mobile use. 5G and edge computing are important enablers. They allow fast offloading of heavy computation so that the phone does not need to handle everything locally. Low-latency networks help the device update holographic scenes in real time based on movement and interaction. This opens the door to cloud-enhanced holograms where much of the processing is done remotely but appears instantly on your screen. Consumer adoption will depend on price, usability, and killer apps. Early models may be expensive and limited in functionality, but as more developers create compelling uses and as the hardware becomes more refined, prices should drop. Analysts expect the first generation of holographic phones to serve as premium flagship devices before gradually becoming mainstream. Privacy and security are new concerns. A holographic display can be seen from various angles, which makes it easier for others to view sensitive content. Engineers are working on directional projection that limits visibility to the primary user. Eye tracking can also be used to blur or mask parts of the image when the viewer is not authorized. These safeguards are critical, especially for enterprise and medical use. There is also the matter of ergonomics. Interacting with mid-air images can cause fatigue if not designed properly. User interface designers are testing new gesture sets and feedback systems to make sure interactions feel natural and do not strain the user. Haptic feedback or subtle audio cues may be added to enhance the experience and reduce disorientation. Camera technology is advancing to match the display innovation. Depth-sensing cameras and LiDAR modules are being refined to capture the real world in 3 dimensions. These tools allow the phone to understand its environment and adjust holograms accordingly. They also enable real-time 3-dimensional video capture, which users can send as holographic messages or display in their space. Education could become one of the most transformative applications for holographic smartphones. Students might study anatomy using floating 3-dimensional models or explore historical events through holographic reenactments. Language learning could involve conversational avatars that respond to voice and gesture. With content that moves beyond flat screens, learners of all ages may retain information more effectively by engaging multiple senses in an interactive 3-dimensional space. As holographic smartphones evolve, we may also see entirely new social behaviors emerge. Friends could gather virtually around shared holographic projections, playing games or collaborating on creative projects without needing additional equipment. Dating apps might include full-body avatars or holographic introductions. Over time, these technologies could change how we perceive presence, bringing remote interactions closer to the feeling of being physically together. The entertainment industry is especially interested. Studios are experimenting with holographic trailers and virtual concerts. Music videos may include floating scenes. Fans could project their favorite artists performing live right on their kitchen table. Game developers are designing mixed reality experiences that respond to voice, motion, and even eye contact. The race to bring holographic smartphones to market is well underway. As the technology matures, we may see a shift in how we think about screens altogether. Instead of staring at rectangles, we will look into digital spaces layered atop our own. These devices will not just change phones, they will redefine personal computing for a new era. Thank you very much for watching. Please like and subscribe.